So, here also you can have single or multiple stages. The other option which is non positive displacement are fans, they are generally used where high flow volume capacities are needed, but at low pressure. So, in such cases fans are used and they can be centrifugal or they can be axial. I am sorry, let me see what is here. Oops. Yeah. So, obviously compressors apart from that mechanism requires other accessories, like for example lubrication. Lubrication is very important in pneumatic systems, firstly because they are not self lubricating just like hydraulics. So, you have to have special lubrication mechanisms here, and second also because there is the tendency of air to leak is actually much more than the tendency of oil, because air has very low viscosity and oil has high viscosity. So, oil does not tend to leak out as easily as air does. So, so therefore, all seals everything are much tighter to prevent air from leaking, and that creates a lot of friction. So, lubrication is more necessary. Similarly, cooling, because the compressor is actually doing a lot of work. So, a lot of heat is produced which needs to be cooled, and you need unloading systems. Compressors are energy guzzlers. So, whenever you do not need when you have created adequate compressed air supply, then there has to be mechanisms by which these compressors are actually unloaded. And finally, there has to be control mechanisms for shutdown as well as for duty cycle control. Duty cycle control means that especially stroke length control and for how much time you are going to, that is how quickly you are going to operate the piston. So, all these control devices are will actually operate the compressor at in such a manner that the current requirement of compressed air will be met at the with the best possible energy efficiency. So, the compressor is generally not run when the compressed air supply is not so much required. So, compressors, so for example, this is a typical compressor where this is we can see from the picture that this is a IC engine driven compressor, and this is the compressed air supply. So, that is the accumulator, and it looks like it is portable. It is just a picture which is downloaded from the net. So, compressors are available at various sizes or capacities, and so 150 psi up to 150 psi would be low pressure, 150 to 1000 is medium, and greater than 1000 psi will be high pressure. The capacity of the compressor, so there is a pressure rating which is decided, and then so compressed air is actually supplied at that rating, and then the capacity of the compressor is basically decided by the volume of air that it can deliver in minutes at that pressure. So, it is often in engineering it is often described in terms of CFM. It is called CFM, cubic feet per minute. So, how many cubic feet per minute of air the compressor can supply. So, that generally indicates its capacity. Now, we have pneumatic reservoirs. As we said, this is a typical picture. It is just a container with one inlet and one outlet, and holds air under pressure, and the capacity of the basically that is the pneumatic energy. So, the pressurized air is the pneumatic energy which is used to do work, and the amount of energy that can be stored is basically decided by two quantities, that is at what pressure, how much air is stored and what is the pressure. So, they are generally a multiplicative relation, because volume and pressure are both. If you have high volume and high pressure, then you are going to have high energy. So, as I said, that it stores pressurized air for fast delivery of air volume, and it's like a capacitor somewhat. If you appreciate an electric analogy, then just like for suddenly supplying large currents without causing the voltage to drop, we always connect a big capacitor across a power supply, because the capacitor can supply a lot of current instantly, and therefore, I mean, as long as it has the charge to supply the current. So, therefore, capacitor is generally kept charged at the circuit output, so that current demands, large transient current demands can be met without causing the terminal voltage to drop. So, in that sense, the accumulator is actually a capacitor. Now, the pressure in the accumulator, you say, as the pressure in the accumulator has to be controlled, because so as if air is really drawn from the accumulator at any time, then the pressure in the accumulator will fall, and then we need to make up for that loss of pressure and make the pressure again back to the standard one, and that is typically controlled using a relay with hysteresis, and then used with pressure regulator to actually deliver to valve and cylinder at around 60 psig is a very typical figure. So, the control is somewhat like this. It's just like it's just like level control, very simple, that suppose the regulator is actually designed to work at 120 psi, then there is a hysteresis in the sense that I don't know why this is happening. I don't know why this is happening. Anyway, just a moment. This is working. Okay. So, you see, what we are trying to do is that if you have had a pressure setting, suppose if you have had a pressure setting of, let us say, 120 psi. Now, as you are drawing load, so this pressure will start falling, and then at 115 psi you again turn on the compressor such that the pressure keeps rising and becomes, so that the pressure will so you actually make the you actually turn on the compressor at this point of time, and then the pressure builds. Now, as the pressure builds, so you are moving along this line, the compressor is now on, and then you actually, although you want to keep it at 120 the 120 psi is the nominal voltage where you want to keep it, but you actually let it build up to a certain point, let us say up to 125 psi, and then again when it reaches 125 psi you actually stop it. So, you come here, right, and then again as the loads will draw the air, so the pressure will fall. So, you actually move around through this what is called hysteresis rectangle, right. So, now okay, but there are, so this is one, this is the way of controlling the reservoir or the accumulator. Now, there are many other pieces of equipment needed, like for example, you need pressure regulators. Now, why you need pressure regulator is actually very simple. That is, you see, generally in pneumatics you have one pressure source, right. So, suppose this is the compressed air source, So, as we have just now seen that firstly, and from there generally typically a kind of duct or bus runs which provide air supply to a number of equipment, right. And firstly, all these equipment may not be operating at the same pressure. So, some of them may be working at, let us say 50 psi, some may be working at 120 psi, whatever. So, but the fact is that, remember that we said that why a pneumatic system is cheap. It is cheap because you are going to use one compressor. So, the compressor cost is going to get divided. So, just because these are going to require different pressures. So, we are not going to connect 3 different compressors which will individually supply this equipment. So, therefore, we need a device here, which will take in this, maybe this is some 300 psi. So, which will take in this 300 psi pressure and will convert it to 50 or 120. So, we are going to put, actually we are going to put different pressure regulators for all these equipment and have a single compressor. So, firstly that is going to be cheaper. Second thing is that, as we have seen just now when we saw the hysteresis controls of that of the reservoir, that this pressure source is going to fluctuate, but for our operation, precision operation, it is not good that the pressure supply of this equipment fluctuate. So, therefore, if we put a pressure regulator here, then that pressure regulator is firstly going to convert a high pressure level to a low pressure level, and secondly it is going to, so even if the pressure here, so suppose this is a 300 psi bus, so even if the pressure here varies 300 psi plus minus, let us say plus minus even 50 psi, but the pressure here is even if it goes up and down, the pressure here is going to be regulated by the pressure regulator to exactly very close to 60 psi. So, the pressure regulator actually does these two jobs. It first converts pressure levels, and secondly it holds the pressure steady. Secondly, as I said, that we need lubrication. So, lubrication is needed, as I said, that firstly it is not self lubricating, secondly because of tightness of seals you tend to increase friction. So, therefore, explicit lubrication is necessary, and we also need lot of air filtering, because we are sucking in air from the atmosphere which contains many particulate matters, and which are going to get clogged inside the equipment and then cause further problems of maintenance in terms of sealing misses, in terms of increased friction, etc. So, we need equipment to take care of these. So, a regulator is used to drop pressure to a level which is appropriate for a machine, and it prevents pressure fluctuations on the air distribution duct to reach the machine. And settings, generally for regulator settings can be adjusted, and it is self relieving in the sense that if the pressure, I mean there is too much inlet pressure, then it generally relieves that pressure. So, this is just a typical picture of a pressure regulator, and so you have this high pressure inlet, you have the low pressure or the controlled pressure outlet. So, this is going to the system or the equipment where the pressure is needed. This is typically coming from the reservoir. So, now the pressure setting can be adjusted by this pressure adjusting knob, and often there is a pressure gauge, so that one can see that the inlet pressure variation. So, then the filter can be connected is generally connected at compressor intake, and various types are possible. Paper element type is a popular one, and sometimes you put additional filtering you need just before the equipment to ensure further that these are that your components are protected, and so it removes the large particles, and it also removes moisture, because especially particulate matter and moisture creates a very sticky mix which leads to all kinds of problems like increased friction, sticking. So, the term stiction actually comes from that. So, the static friction may increase substantially unless moisture and this particulate matter is not removed. So, we have explicit lubricators because air has little lubrication and low viscosity, and so the lubrication is generally achieved by spraying fine oil mist to air flow. So, it is very difficult to in a distributed system to lubricate the system. So, just like in hydraulics, the oil itself is the lubricator. So, as it travels throughout the system, it actually lubricates the whole of the system. In this case, air is not itself the lubricant, so, but it is nevertheless traveling throughout the system. So, it is simple. So, the delivery of the lubricant can be easily done using the air itself. So, therefore, lubricating oil is actually in a kind of atomized form. It is spread to the airflow, and then the airflow takes it to various points and where it provides the lubricating function. So, if you have smaller droplets, you have longer lubrication, and sometimes you can have atomization. But this oils, remember that the moment you are going to put this oil mist, you cannot directly release it. You can release it, you need not return the air, that is fine, but at the same time you cannot release the air just like that into the atmosphere because of that oil mist, because it is going to be health hazard. So, sometimes, so you actually before releasing into the atmosphere, it must be, this oil must be filtered. Since this filtering, regulation and lubrication are very common requirements. So, we have like combo units where this filter, regulator, lubricator are designed together. So, filter plus regulator plus lubricator unit, typically this is a symbol. So, you have regulators, lubricators and naturally filters. So, typically some typical pictures of these equipment. Then we come to direction control valves, right. These are very similar to the direction control valves that we have studied in hydraulics, and it controls and changes direction of airflow from time to time. There are various functional types, as we know. It can be 2-way, it can be 3-way, it can be 4-way, even it can be 5-way. There are various positions. So, it can be a 2-position or it can be a 3-position valve. So, what I mean is that based on their functionality and based on their construction, there are various categories of these direction control valves. For example, this is a typical 3-way valve which is manually operated using this knob, and it has 3 operational modes. So, namely off, vent and on. So, it can be made off, in which case air will not flow. If it is on, then the air will move from inlet to the outlet, and if it is in vent mode, then the inlet and outlet will be connected to the atmosphere. Looking at some very typical valve case studies. So, very standard, this is a double acting cylinder, and so double acting means we need to move it this way as well as this way. So, here we have connected, this is a 2-port valve, this is a 3-port valve, this is a 3-way valve, 2-position. So, it can connect either this to this, or it can connect in this position, it will connect this to this, and this side will be can be again connected either. So, they are actually independent. So, depending on the positions of these valves, if they are in the position shown, then this side is also pressurized and this side is also pressurized. So, the valve is locked, right. On the other hand, if you connect this end to this position and this end, if you connect to this position, then what happens is that then the piston will start moving right, because this chamber will be connected here, but this chamber will be connected to high pressure. So, the piston will start moving right, and then there is vice versa. If you connect it the other way, this in this position and this in this position will start moving the other way. If you keep both of them, so there are four combinations, and if you keep both of them in this position, then actually the cylinder is floated. So, it can move, it is free to move because both ends are connected to vent. So, yeah, so AB to P locks the piston and AB to E locks, E means exhaust, the piston is floated. Similarly, this is a case where this is a 2 position 5 ported 4-way valve. So, 5 ports, because 1, 2, 3, 4, 5 ported, and 2 position, because this is one position and this is the other position. Okay. So, what happens is that sometimes these pistons, when they are moving the load, they will require high pressure operation, because a lot of force is to be created, and when they are returning, then it is a low pressure operation. So, what happens is that, see that the low pressure source is actually connected to this point, this is sealed. So, this motion is going to actually occur, and this is connected to exhaust. So, this is the return position. On the other hand, when it is moving this way, so this is the rod. So, the load is going to be connected to the load. So, when it is pushing the load, at that time this is the high pressure position, HP forward position. So, in that case you can actually drive it using your high pressure source, right, and so that will possibly save some energy. Similarly, this is another application where for example, see this is a 3-way valve application, where if you connect it to this position, then the valve will move this way. These are springs. So, valve is spring loaded, and so therefore, for the return you do not need any pressure, and you just shift the valve. So, this will get connected to this port, which is exhaust, and then by spring action, since this side, when it is connected to exhaust, this side pressure is low. So, by spring action the valve can return. So, you need only apply pneumatic pressure for moving the valve to the right, for movement to the left is actually achieved by the spring. Similarly, if you connect it to this position, then what happens is that the pressure gets connected here, and then when this valve is in this position, you see, so this is sealed, while the high pressure will go and the low pressure will return. So, the cylinder will move this way. If you now shift this valve, then what is going to happen is that the high pressure will go this way. So, high pressure will go this way. So, it will be applied here, it will be applied here, and the this other side will be applied here. So, it will be exhaust. This is also exhaust. These two are vents, this is vent and this is vent. So, then it will move this way, right. On the other hand, if this valve is shifted to this position, then what happens is that both sides of the cylinder, for example, then this side of the cylinder is free, for example, if the valve is in the position shown, then this is sealed, right. So, therefore, this chamber is sealed, while this chamber is open. So, what happens is that now if you want to push the cylinder, then the air will get compressed and some force will be created. So, it cannot be freely moved, So, it gets kind of soft locked that way. So, you can have various sorts of such circuits, and we will see some of them later in our next lecture. These directional valves, sometimes they have to be moved, we were talking about moving the directional valve from this position to that position. So, how do we move that? So, there, as just like in hydraulics, there are various ways. So, you can have manual, where you can have a push button, you can have a hand lever, you can have a foot pedal, whatever you have, or sometimes for very large valves we can, for example, this is you can have a pilot valve. So, this is a large valve. So, to be able to shift that position, you see pneumatic pilots are used. So, this is a pneumatic pilot, which is used to shift this main valve, right. This may be a big hydraulic valve also, and this hollow triangle indicates pneumatics. So, you can have hydraulic pilots, you can have air pilots. So, even a large pneumatic valve can be driven by a small air pilot, and or otherwise they may be solenoids, and sometimes, as we have seen, that they may be spring loaded, such that the especially the return stroke as such does not require an actuation force. So, these are the various ways of actuating a directional valve. Oh, sorry. So, this brings us to the end of the lesson. So, what we have seen is that we have seen the pneumatic system principles and benefits. In particular, we have seen that we are going to, in pneumatic systems, we are going to use compressed air, and not only that we are going to use compressed air, we are so compressed air has some benefits, that air is free and it does not require a return line, etc. But on the other hand, because of the compressibility of air, the system response tends to be slower, and there is another big benefit compared to hydraulics, is that the fire safety is much more intrinsic. And so, basically it means that there are certain very definite classes of application. We have also seen that in certain cases where you need a lot of low power applications spread over a large area, pneumatic systems come very much cheaper, because it's you can use one compressor, and then you can use an air duct system to actually reach the pneumatic power to a large number of places without requiring too much ducting costs. So, there are certain kinds of applications where pneumatic systems are quite well suited compared to hydraulic systems. So, it's just a question of it's just a question of the particular kind of application where these systems become more beneficial. We have also seen the main system components, in the sense that we have seen talked about compressors, talked about accumulators, regulators, and some kinds of direction control valves as well as the cylinder. Now, there are various other kinds of elements which we will talk about in the next lesson. So, we have seen the major kinds of system components. Compressors we have seen, mainly the compressors which are used are reciprocating or reciprocating compressors. We have seen how they work, and we have looked at some pneumatic control valves, various kinds, and we have also talked about accessories such as lubricators and filters. So, coming to the end, before the end, let us look at some easy, relatively simple questions. What are the main advantages of pneumatics over electric systems, and so what are the main advantages of pneumatics over hydraulic systems, and can you, so for example, one thing could be, can you name some applications where a hydraulic system is preferred? Can you name some application where a pneumatic system is preferred? And identify the major components of a pneumatic system. So, major components, we have discussed this. Name 2 major types of compressors. So, 2 major types of compressors could be reciprocating, could be rotary vane type, could be fan type, non positive displacement also. Then 3 different types of directional valves. So, we have seen these and draw their symbols. So, this is of course very similar to hydraulics. So, that is all for today. Thank you very much.